Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 6.2 of our virtual algebra 2 text on complex numbers. We're going to be taking a look at how to graph complex numbers. A sample problem is presented here where you have to graph the complex number 3 plus 2i. If this looks like what you're looking for, don't forget to hit the like and subscribe buttons. We have 4 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the contents of this presentation. To gain access to our entire Algebra 2, Algebra 1, Pre-Calc, Geometry, and Calculus courses, just take a look at the links in the description below or visit our website at Mathgotserved.com. Instructions for the examples that we're working on are as follows. We are to graph the given numbers on the complex coordinate plane. All right, so for question number 1, what if we are to graph the complex number 3 plus 2i? All right, so how do we graph this? All we just need to do is identify the real and imaginary parts and then represent that as a coordinate system, as a coordinate point, and then we just graph it. Okay, so if we have 3 plus 2i, we just have to remember that complex numbers in rectangular form is given by a plus bi. The a component is the real part and the b component is the imaginary part. So if we want to write this as a point, 3 plus 2i basically on the coordinate system is given by 3 comma 2. All right, is AB, that's what it is. So we're graphing the coordinate points a comma b. So a is 3 and b is 2. So this is the real part and then the 2 is the imaginary part. Okay, all right, so let's label our coordinate system that we have here. So the x-axis, our standard x-axis, the horizontal axis, is the real axis, okay? Is the real axis. This is where you graph your a value. And then the y-axis is your imaginary axis. That is where you graph your b value, alrighty? So in this point 3, 2, we're just going to look for 3 on the y and the x-axis or the real axis, 1, 2, 3. And then 2 on the imaginary axis, 1, 2, and then this is where they meet right here. This is the graph of the point 3, the graph of the complex number 3 plus 2i in rectangular form. We see that it's a rectangular form because if we graph it, we kind of have like a rectangle right here. Okay, now let's take a look at question number 2. Let's say we are to graph the complex number 2 minus I. Okay, let's take a look at that one. So here we just have to find what a and b are and then we're good to go, okay? So 2 minus I, if you notice, I does not have a coefficient, so it's going to have the invisible coefficient, which is just 1. Okay, so in this particular scenario, our a is 2 and our b is going to be -1. So if we want to graph the coordinate point AB, so this is a plus bi. If we want to graph the point AB, we're just going to use 2 as a, and b is, you also take the sign, okay, -1. So that's how we are going to graph it. We're going to graph 2 on the real axis and -1 on the imaginary axis. All right, let's label our axis. This is our real axis right here, the horizontal axis, that's the A. And then this is our imaginary axis right here, that's the B component. So we're graphing 2, -1. So we have 1, 2 on the real axis, and then -1 on the imaginary axis. And this point right here is the complex number 2 minus I. Okay. All right, let's take a look at another example. How about graphing the complex number -2i? So in this particular case, we have a pure imaginary number. So how do we graph something like this? So we have negative 2i. How do we write this in a plus bi form? This is the imaginary part. The real part is not there because it has the value of 0. Alrighty? Okay, so we have a plus bi. Can you tell what a and b are? In this setup that we have right here, I want to graph the point a comma b. In this setup we have right here, a is 0 and b is negative 2. Okay, so all we just have to do is graph the point 0, negative 2, and we are good to advance. Let's do it. So let's label our axis first. This vertical axis is our imaginary axis. That's where we're going to graph our b value. And then we know that the horizontal axis is the real axis. We just use this right here, okay? So just go down 0, negative 2, just go down 2 units, 1, 2. Right here, ladies and gentlemen, this is the complex number negative 2i. Okay? All right, so now what if you're given the graph of a complex number on a complex coordinate plane, and you're to determine what complex number is graphed? Let's take a look at that. Okay, let's take a look at question number 4. So question number 4, we have the graph of a complex number on a complex coordinate plane, and we have to determine what complex number is graphed. Okay, all right, so let's go ahead and do this. So if we want to determine what complex number is graphed, we just need to figure out what the value of a and b are, and then we're going to insert it into the a plus bi formula, and we are done. Okay, so we know that the a component is the real component, this is a, and the b component is the imaginary component, that's b. So let's find the a value first. We're going to the left, 1, 2, 3, 4, 5, 6. To the left, so that's negative 6. So that's our a value. Okay, a is negative 6. And then b, we're going down, 1, 2. So our b value is negative 2. So b is negative 2. When we insert it into this rectangular form, we have negative 6 minus 2i. Ladies and gentlemen, this is the complex number that is graphed on the complex coordinate plane to our left. Now it's your turn to do some practice problem to demonstrate mastery of the art of graphing complex numbers. Alrighty, so here are your 4 practice problems. Number 1 to 3, you are to graph the complex numbers given on the given complex coordinate plane. And then number 4, you're to determine what complex number is graphed on the complex coordinate system. Alright, so go ahead and pause the video presentation at this time. Try these problems. When you're done, click back on the play button, and then we will reveal what the correct answers are. Welcome back. Hopefully you had a chance to try the problems. Let's take a look at the graphs. The points that are graphed. So 4 minus 4i, this complex number is obviously 4, and b is negative 4. So we're going to go 1, 2, 3, 4 for the real part. The imaginary part is negative 4. 1, 2, 3, 4, negative 4, and 4. They meet right here. Bam. So that's the answer. This point right here is 4 minus 4i. For number 2, a is 1, b is 1. So 1 on the real and 1 on the imaginary. So this point right here is the complex number 1 plus I. Number 5, a is 5, b is 0. So 1, 2, 3, 4, 5. Right here is the point. This is a graph of the real number 5, or you could call it you could call it 5 plus 0i, because the b component is 0. That's why you end up with 5. So 5 plus 0i is the same thing as 5. Okay, number 4, we have a complex number graph. So what's the complex number? 1, 2, 3. We have -3 for A, and then 1, 2. We have 2 for B. If we put it in the complex number formula, a plus bi, the answer is going to be -3 plus 2i. That's the complex number that's graphed in question number 4. Alright, so how well did you do in these 4 practice problems? Let us know how well you did in the comment section below. If you have any questions, comments, or thoughts about what we went over in the tutorial or in this practice set, just specify it in the comment section and we'll be more than glad to respond. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your studies of complex numbers, do give us a thumbs up or a like. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel for updates to other presentations such as this. Tons of support resources can be found at Mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.